So hi everybody, I'm Arden Meyer. If you were here last time I talked, you already know me. If not, well, I'm still the same guy. So what I'm going to be talking about today is privilege escalation in a master keyed system. So that's like what you would have on your college dorms or in a lot of office buildings. So to start off with, I am building on some other people's work. Matt Blaze wrote a paper, published a paper back about 15 years ago, and then most of the diagrams, anything animated, almost everything animated on here is courtesy of Dave. I'm not the big graphics guy. So give credit to the other people that helped out with this. Who am I? I'm retired Master Sergeant, Air Force, and then right now I'm working on my PhD at Iowa State. Nobody really cares. All right, to the good part. Yes, we do have rules. If you ever sat in Lockpick Village, if I've ever taught any of you how to pick locks, you'll know we do have rules. First, don't pick locks that you don't own. Second, don't pick locks that you rely on, your front door, your back door, anything that you actually use. For this talk, I have a third rule. Do not go home and do this without permission from your boss, your landlord, the school administration. You probably are going to get arrested, go to jail. Most likely they're also going to charge you for rekeying every single lock in the system, which is going to run thousands and thousands of dollars. Don't do this. This is education only. All right, so this is what a normal lock looks like. What do we have this DSM background? Say something's bleeding through here. Cool. So this is what your normal lock pin stacks are going to look like. But we're here to talk about master keyed systems, like what we'd have in big buildings, college campuses, other apartment complexes, I think is what that was supposed to represent. So here's an example of what a master key system looks like. We're still having some color issues. This should be green, the black bars. And it is on my screen. I don't know what's going on here. But so in a master key system, in between your driver pin and your head pin, you have some master pins. That allows multiple lock or multiple keys to operate in this type of lock. So in this example, for these pins, the pin on the left, only a key cut to the 8-bit depth is going to work. But on these other two, either a 6 or an 8 will work because we have a 6 depth driver pin, and then we have a 2-depth master pin in between the driver pin and the head pin. So in a master key system, we have multiple keys that are going to work. So here's Alice's key. If you're up really close or if you turn around and look at the screen behind you, you can actually read that it says Alice on it. We have Bob's key. We also have Andy's key. And most importantly, we have the Janitor Key or the master key. This is the key that will get us into almost every door. So here's the different bit depths that we have. Now, for all of these examples up here, just for ease of use, we're using a quickset keyway as an example. So we only have 5 pins and we only have 7 bit depths. Each key is a little different, or each keyway. For example, the SC4, which is the one that I like to use for numbers. In an SC4, you have 6 pins and you have 10 different bit depths. I like that for numbers because it's really easy to do 10 to the 6th power. Here for quickset, you have 7 to the 5th power. I'm not going to do that math. Anybody that's a math whiz want to go at that one? Okay. But so here's the different bit depths that we have. And as you can see, each key is unique. Well, we'll set up with different keys or different keyways, and we can see that Alice's key will work in Alice's lock on the upper left, but here's Alice's key in Andy's door. We have a couple of, the 2nd and the 5th pin aren't going to work. Alice's key in Bob's doorway, and we can see that 4 of the 5 pins aren't lined up. Alice's key is cut to 36235. Here we have Andy's key in the same key depth, or in the keyways, and you can see that it's not going to function on Alice's lock. It's not going to function on Bob's lock in the lower left. It will work on Andy's door, as you'd expect it to. Andy's key is cut 35233. The next one that we have up, we have Bob's key. Again, as expected, it doesn't work on Alice's door. It doesn't work on Andy's door. Or Andy's door, but it does work on Bob's door in the lower left, again, as expected. Now here's the Janitor Key. So the janitor key is going to work on Alice's door. It's going to work on Andy's door, but it actually isn't going to work on Bob's door. So Bob's door is not in this master key system. You can have master key systems set so that there is one universal master key. You can also have them set to different tiers. So if you have a very large, say, college campus, you have certain janitors that work in certain buildings. They only have a key that works on their building. But security needs to be able to get into every room. So security has a top-level master key. So this is an example where even though we're master keyed system, the janitor key, in this scenario, Bob is in a different building. All right, so let's start with Alice's key. Alice's key with it's called a change key. Her bidding depths, again, were 36235. So obviously it's going to work in her own lock. What do we know about the inside of that lock? Maybe not going to be doing as much class participation. Okay. So on the inside, we know the simple solid pin. So this is if it wasn't master keyed, we know that we can cut at these bit depths. But what we don't know is that we might have some master pins in there. So what we want to do is we want to be able to decipher those. So since they're all hidden, what we can do, though, is we can prepare an exploratory key. So since we know what bit depths do work, we will cut 4 of these. The second, third, fourth, and fifth, we'll cut them to the known depth levels, but the first pin will start at depth 0, and we'll try from there. So we'll leave these as we already know from the original change key, the key that Alice was given that works on her door, and then we'll start at the first pin, and we'll leave it at 0. We're going to sweep this entire range, so 0 to 7 in the case of quickset, and if we're wanting to be even more specific or more literal to the specification, the 0 depth is not a legitimate key depth for quickset. In some systems it is. In quickset it's not. But on occasion you will still find locksmiths that will cut a door at 0 depth. So one of the things that we have to be aware of whenever we're playing around on the inside of locks is a thing called MAX, the maximum adjacent cut specification. So what this is your adjacent key wells, if you have too large of a gap, you can actually get your pin stuck down inside the key and you cannot pull the key back out. That's really bad if you've been messing around on a door doing something you weren't supposed to and now you can't get the key out. This is how you get caught. So be aware of your max. So what we're going to do is we're going to file that position down 1 bit. So we're just going to manually take a file. And if you want to be a little high tech, you can have a depth gauge like this, or you can actually just look up the specification for your keyway and know what each bidding is. So we're going to file it down 1 bit. Technically, we still have a max violation here because on quickset, your max is a 4. So we've got a 1 and a 6. That's a delta of 5. So we still have a max violation, but give it a shot. We try it in the lock, and it won't work. We take the key out. We file it down to the next bidding level, depth of 2. Now we're out of that max violation. So although these look different, they are still the same bidding depth. What we're showing here is that I'm manually taking a file on that first one, whereas the second, third, fourth, and fifth pins have been cut by a key cutter. But that's actually still the exact same depth. Again, max isn't violated now. We'll give that a try. Lock still doesn't open. Wash, rinse, repeat. We remove the key. We file it down 1 more position. We try it again. Hey, it opens. But anybody surprised that opened? Nobody was paying attention to what the original key was. We've just replicated the original key. So what we have actually learned, though, is that we do know that top pin is solid. I'm sorry, the driver pin actually is solid. But we can still have some master pins in the upper portion. So we're going to continue. We're going pull it out. We're going to file down one more position, try the key. Doesn't work. Now, we could skip this step because one thing that we don't do in the locking world, we don't have master pins that are only one bitting thick because that's actually too thin. And if you have a one bitting depth wafer in their pin, they tend to get jammed up. They tend to start to turn and it'll cause a lot of malfunctions. So you don't actually ever have bit depths, a master key of one bitting depth. But we'll try it just in case. We'll file down to the next bitting depth down to 5, and we'll try this. Doesn't work. We'll remove the key, file down one more time. We'll try the key. It opens. Now what have we learned?
Bidding depth 2?
Well, we're at bitting depth 6, but the original key had a depth of 3, so now we know that there's a 3 bitting master key in here. There we go. Here's the side I'm looking for. So now we know that we have, hey, we got my green back, thanks. We know that we have a 3 bitting master key or master pin in there at the first position. So we now know our entire first pin stack. We know that because, again, the maximum depth on this particular specification is 7, and as I said, you will never have a 1 bitting key or 1 bitting pin. But just for fun, I believe my slide deck shows that we'll try the next, we'll try 7. Of course, it's not going to work. So now we know that first pin stack. As the slide says, quickset depths don't go past 6 or 7. So we're going to go, now we take another key and we prepare for the second pin. So we will cut our first to the what we just discovered as a master pin depth. Pins 3, 4, and 5 will cut to our change key, the one that we know that we were given for our office door or Alice's office door. And we'll start back over at 0. Again, these are the 3 that we already knew. So again, oops, back arrow. So again, 0 is almost never used by its specification. It's not supposed to be used. The pins do exist to do it. There have been locksmiths that have used 0 in master key systems. You'll see it in challenge locks occasionally, but it shouldn't actually be used. So this is where knowing your system comes in handy. So we'll save time. We're just going to go ahead and start at number 1. We file that down to number 1. Again, max is technically being violated here, but we're going to give it a try. Lock doesn't work. Go down to the number 2. We're out of our max violation. We try it in the lock. The lock does not open. Seeing a lot of repetition here. Okay, so we get down. 3 didn't work. 4, we try, and it opens. So now we know, here we go. Now we know our 4, or our second pin, has a working at 4, and we have the original from 6. So that's what we knew earlier. We still don't know about these other 3 pins. So we're done here because we've found the master key bitting at 4. We already knew 6 from our change key, and we know because we don't ever do 1 bitting pins that there's not going to be anything at 5 and 7. So we knew that one from our change key again. A lot of slides to say the same thing. Okay. So basically we're done with key number 2, or pin number 2, How come? Because I just explained it, because not a whole lot of class participation here. All right. And I'm just rambling. All right. So again, single depth mastering pins, they're rare and bad. I would call them more than rare, unless you're messing with some sort of challenge lock. You don't see these in the operational world because they get jammed. Although most of us are IT sec, we know that when your users are having problems, that means you're having problems. And if you've locked your user out by putting in a bad pin, now you're having a bad day too. Okay, so again, 5 is highly unlikely. We could try it. We could file down to the 6, but we already know that 6 works because that was the change key. That was the original key that Alice had. And we know why we don't care about 7. All right, now we have 3 chambers left. So we're gonna, again, create another exploratory key. We're gonna cut depth 1 down to our master, or pin 1 down to our master. Yeah. So would this be a valid key?
No.
Why?
Because you're max.
Because we have a max violation, exactly. But, and again, max is specific to the keyway. So if this were a Schleg, like the SC4 that I mentioned earlier, Schleg's max is 10, which in essence means that it doesn't have a max. Depends on your keyway. So pin 2, we're going to cut it to depth 4, the master cut that we just found. Position 3, what are we going to cut position 3 to? Anybody other than Jared? I'm forcing class participation. In the back, correct, 1. We can leave it blank or cut it to 1. 0 we know isn't actually used in the real world. For the rest of the key, we're going to cut to our original key, the change key, 3 and 5. So off we go. But before we do that, do we remember what the change key's known depth was on that 3rd pin? It's up there in gray. Come on, try. 2. So we know that we don't actually ever cut to 0. We won't go to a 1 because we don't do 1-bit depth master pins. We know that 2 is a working key. So what's the first depth that I want to cut this to? Okay, now I'm starting to get a consensus. The 3's changed to 4s. You remembered not to do that 1. Originally, I had about half of those hands were holding up 3. So yes, we can go ahead and jump 1, 2, and we know 2, 1, and 3 are not things that we want to mess with. So we'll start with 4 as our starting point. So we've also eliminated a lot of waste if we're trying, wasting time. So we've prepared our key number 3. We give it a try on number 4. It doesn't work. We remove it. We file it down to number 5. We give it a try. It works. We found the master pin for the 3rd pin. So this tells us quite a bit. We now know that we have master pins in the first 3 positions. Now, could we have anything more in that 3rd pin? Crickets. All right. We could. Remember, 7 is a valid position, and you can have multiple master pins. Because again, you can have this in tiered so that the janitor can only get into a certain building, but security can get into all of them. Or your CEO, for some reason, thinks he needs to be able to get into every room. We never have that, right? Okay. So anyway, position 3 really does look dialed in. We can try depth 7. We know that we don't want to bother with 6. We could try 7. It's possible, but at the moment, for speed, I would just set that aside. I remember that I hadn't tried that if I wanted to come back to it. But for speed, I would move on. Go take a look at the 4th pin depth, or the 4th position. Preparing our 4th key, we'll start out by cutting the first 3 pins to our known master key positions. The 4th position, we're going to leave at depth 0. And our 5th position, we cut it down to our known change key, so depth 5. So again, for quickset, this is going to violate our max, but who knows? So we can sweep this entire chain, or we can sweep this entire range, 0 through 7. But we know that we have a our change key had a bidding depth at 3 in the 4th position. So what positions do we want to try? Where do we want to start? Okay, I'm hearing more ones. Yeah, we actually do want to test position 1. Your master key doesn't, or your master pin doesn't have to be below. So we'll try 1, and then we'll jump right on down to 5. Try 5, 6, and 7. And okay, we do have a minor font issue. The number 7 disappeared. So we can either code cut this at 1, or we can just take our file to it. So doesn't work at number 1. We remove the key. What do I file next? We can go straight to 5. If we want to, we can screw around with number 3, but that better work. That's what our known key was. Of course it works. So then we jump to 5, try the key, it doesn't work. Go down to 6, try the key, doesn't work. Go down to 7, try the key, doesn't work. So what's going on? You don't have to have a master pin in every position. Your door just happens to have, the 4th position on your door is the master position. So don't panic if you don't find a master pin in every position. That's fine. You're most likely going to have at least one of your positions doesn't have a master pin in it.
Would that probably be cut everywhere then?
A little louder?
Would that probably be cut everywhere then? That 4th position, would every lock have that?
So the question is would every lock have that position depth? So that would be a valid position depth because we know that's the only one that works on our door. So the master key must be at that position. That doesn't mean everybody's key, though, is cut at that depth because they can have master pins in their locks. So not everybody's key is going to look the same in that 4th pin, but we do know that the master key is going to have is going to be cut at that depth. Okay. So far we now know 4 out of the 5 of the master pins. So for the 5th one, again, this is a lot of repetition. Wash, rinse, repeat. So we start either depth 0 or 1. Like I said, for speed, honestly, I would do 1. 0 is not a valid by its specification. Right off the bat, it works. Yeah, there we go. So depth 1 works, and we also know our master or our change key. So we now know 2 biddings that work in the 5th position. Do we want to keep going? I personally, for speed, I now know the master. If I run into some problem later on, maybe I'll come back and try that again because we can have multiple masters keys. But most likely, we now know our master key. So there could be additional cuts in the middle in that green portion. Actually, there could only be 1 more additional cut there. But we now know our master key. So this is what your key is most likely actually going to look like, though, not this, because you're going to be doing this with a little file. I meant to bring mine with. I failed on that part. I left it at home. But in this case, for discovering this master key, you need less than $1 worth of blank keys and a $2 file and time, patience. So this is what your key is most likely going to actually look like. Now, one word of caution, if you are filing your own keys, don't do this. This is what we call canyoning. This will get your pins, your pin will drop down into this position right here, and you won't be able to retrieve the key, and now you're in a lot of trouble. So we now know this is what the inside of our door locks looks like. So we now have the master key deciphered for, here we go. So there's your mastering depths. So now we know what the master key is for all of the locks in this system. Now on the education side of this, or I guess in the practice side of this, If you're doing this in your, in your dorm room, someplace that has no security watching you, you can just blitz through this about as fast as I talked it through. But if you are doing this in a high security area, you can still get away with this. Just it's going to take you a lot more time. It's been done. So again, I come from a military background, from a little bit of intelligence background. Our adversaries have done this to us. So one of the things that they would do is take you would have your key, and you would have your pre-prepared key to test, and you would try just one time, and I used the wrong key, and then use your correct key, and then go home or go at lunch and come back with the next bit depth. So you don't necessarily need to run through this, but this is one thing that if you are in charge of security, and that includes physical security, and you do have people that maybe you don't trust 100%, if you see somebody consistently failing to unlock their own door, you might want to take a lot better look at what they're doing. The hypothetical lock in the same system looks like this. Here's our master key, and it's going to work. So as the last slide here shows, the winner is you. You now have the master key. Do we have any questions from my highly interactive audience? Jared?
Is there a standard for when the master key uses the part above the master pen or below the master pen?
Okay, the question was, do we have a standard for when the master key is going to use above or below the cut line for the master key or for a specification? No, so you will derive the master. You have to make sure that every key in your system, every lock in your system will work on that. And then your change keys for individuals, you just set at any other valid that's at least either uses the same depth or at least 2 away from it, so that you don't have a one bitting. But some, as we can see from our slide back here, some will be above, some will be below. Any other questions? Yes?
Getting the actual depth for where you're at 1 through 7, is there a standard with doing just the pile? Like, do you have some way of measuring that exactly?
So the question is, how do you know the depth to file? This is the problem with having 200 slides.
And I apologize if I missed the first.
Yeah, it was way back here at the beginning. I'm going to show you a specification or a little cheater, and then if you don't have one of these, when I get back there, I got a lot of slides. If you don't have one of these little gauges, they'll run you about $10, and they'll cover your common Schlage, Yale, Sargent, Quickset.
Third off, sorry for missing the first.
Wow. Okay. See, when I built, I didn't remember there being this many slides. Having to go in reverse. My finger is going to be wore out. Holy crap. Oh, there we go. Okay, so yeah, this one here, actually, I guess this is Quickset, Schlage, Weiser, and Westlock. But like I said, these will run you $10. If you don't happen to have one of these, or if you're coming across, you just came across a new system and you don't want to buy this, a set of calipers, and just look up the specification. Again, that's also what's going to tell you how many bitting depths you have, as you can see on this example. So like Schlage goes from 0 to 9, it has 10 bit depths. Quickset is 1 to 7 on the top. You can see the 1 to 7 there. But just look up the specification and use a set of calipers. There are, although not exactly the same thing as this, there's another technique in lock sport that we call impressioning, where I can make a key from scratch, blind, not seeing your key, not knowing, not like this with a privilege escalation. It's called impressioning. The world champion at this, the guy he's so well practiced. Two strokes with his file is 1 bitting depth. He's done this that many times. So if you were doing this over and over and over again, yeah, you'd get that good at it. But for me, I've got one of these for common keyways. If you didn't have one of these, or if like I was going up against, I don't know, some system that's not on my keyway, just use the spec chart and either calipers, or if you're really good, ruler. But you gotta have a pretty good eye if you're trying that with a ruler. But set of calipers and just knowing what the specification says. Any other questions? Yes?
Are the grooves in the side of the key ever used in a master system?
The grooves in the side of the key? So the question, were the grooves in the side of the key ever used in a master key system? So on these types, so the Schleg or the Quickset, those grooves, that's just part of your keyway. There are locks that do have side channels. Medico has some that use a side channel, Byway does, in which case they do. There are different types of locks. That's one of that does lead me to, reminds me of something else. So this concept carries forward to other styles of locks as well. So if you have like dimple locks that have a master key system, it's still the same concept, just instead of filing, you're now drilling your holes a little bit deeper. The concept's still gonna work though. Just it's a little more challenging to pull out a hand drill and not draw attention to yourself. But the concept's still the same. But to your specific question, there are some keyways that do use side channels, but the common ones don't. Again, that also makes it a lot more expensive. And when you're talking about like a college university that has thousands of dorms and hundreds of classrooms, yeah, we're not going to be buying the $2,000 locks per door. So, any other?
How does the locksmith like design the system with the master key and like the sub-master?
Okay, so the question was, how does a locksmith design this system? So, as with any software development, knowing your requirements up front, and don't let somebody change your requirements once you've started. So once you know what your requirements are, if you're just gonna have a single master or if you're gonna have multiple masters, figure out, design, come up with this is what I'm going to use for this, and then just keep to that standard. And for your individual doors, you just keep, you'd have to keep track of every one of them, but as long as it still falls with, you don't violate max, and you don't violate that you only have a one bidding delta, and just, this door is 1111, the next door is 1112, and then you just also make sure that you've got master pins that work on whatever 1337, 311, 31337. Wow, I didn't even get a geek speak joke, or I didn't get a laugh out of it. All right. Any other questions?
So if you have a sampling of keys that all work in the same family of locks or whatever, can you pick out which one the master is versus which ones are a lower level of access?
Okay, so the question, if I've got a handful of keys that are all in this master key system, presumably all change keys, normal door keys, from examining just the keys, can I determine what the master key is? Sadly, no, or good no. But no, because they're cut to what their individual biddings are. Now, the one thing that you would notice in the example of, I'm not going forward 6,000 slides again. In our example, if the fourth position is always the same, say that we're a little bit smaller of a master, not a university with thousands, but we've only got dozens, we may only be using a couple of positions with master keys. You would notice that, wow, all 12 of these keys, the fourth position is always 3. You'd be able to notice that trend. But their positions 1, 2, 3, and 5 are going to be all over the place. So no, from examining just the keys, you cannot determine what the master key is.
If the master key were thrown into that pool, you'd be able to pick it out there?
The question, if the master key was thrown into that pool, no, it really wouldn't help unless it had paint splatters all over it. Because it's just going to look like any other key. Any more questions? All right.